First, I will explain the need for variables within the LabVIEW environment. Then I will explain the difference between local and global variables, showing you examples of each. After that, I will explain how race conditions can occur if variables are used incorrectly. In LabVIEW, the order of execution is controlled by the flow of data or data flow through wires rather than the sequential order of commands like other programming languages. This allows us to create a block diagram with simultaneous or parallel operations. However, in some instances, we have parallel loop structures that cannot be used to communicate data between them because data flow prevents the parallel operation. I will demonstrate this with a simple example. In this VI, there are two while loops that have Boolean indicators within them. When either while loop is executed, then its respective indicator on the front panel should light up. Notice that we are using the same stop button for both while loops. The data for the stop button is being passed from the first loop to the second loop using wires. When I run this VI in highlight execution mode, notice that the loop 1 executed indicator immediately displays a value of true, while the loop 2 executed indicator remains false. When I press the stop Boolean control, notice that although we have the stop button wired to the loop control terminals of both loops, only the first loop immediately stops. Once the first loop stops, the true value is passed out of the first loop to the second, so the second can execute. The loop 2 executed Boolean indicator now displays true. After a wait of 1 second, a true value is passed to the loop conditional terminal, stopping the second while loop. Because there is no more code to execute, the VI stops running. As a result, both while loops do not execute in parallel as intended. This is because the second loop is waiting for the result from the first loop. In order to overcome this issue with data flow, we must use variables. Variables allow us to circumvent normal data flow by passing data from one place to another without connecting the two places with a wire. In LabVIEW, variables can take many forms, such as local and global. Local variables can only be used within a single VI to read and write data between two different locations. Using the same VI we used in the previous example, we will implement local variables so we can start and stop both while loops simultaneously. First, I will change the milliseconds to wait for the wait VIs to 10. Then, I will delete the wire going from the stop Boolean control to the loop conditional terminal of the second loop. In order to create a local variable, right-click the stop Boolean control, go to Create Local Variable. Now place the new local variable within the second while loop. Right-click the local variable and go to Change to Read. Now wire the output of the local variable to the input of the loop conditional terminal. Now the second loop is using a local variable so it can execute in parallel with the first loop. When the Boolean stop control on the front panel is pressed, the local variable reads the new true value and sends it to the loop conditional terminal of the second while loop. At this point, we will not be able to run the VI because Boolean controls associated with a local variable cannot use latch mechanical action. So on the front panel, we need to right-click the Stop Boolean control, go to Mechanical Action, and select Switch when released. Now I will run the VI. Notice that the Boolean indicators associated with each loop immediately display true when the VI is run, meaning that both loops are running in parallel. Then when the stop button on the front panel is pressed, both loops stop running. This is due to the communication between both loops through the local variable.